Welcome back to the deep dive. Today we're jumping into Ruby, specifically Sorbet's type syntax, how it got here, and where it might be going.
Sounds fascinating. It's not often you get a peek behind the curtain of language tool design like this.
Exactly. And our source material is really good excerpts from Jake Zimmerman's Past, Present, and Future of Sorbet type syntax. It's dated April 25th, 2025, but it's looking back at a talk from 2023.
Okay, got it. So kind of a reflection on the journey.
Precisely. Our mission then is to figure out why sorbet syntax looks the way it does. What challenges did they hit? What's next? It's, a lens into language design itself.
Right, because these decisions are made in a vacuum. There are always trade-offs, constraints,
Yeah.
context matters.
Absolutely. So let's rewind. Jake calls it the before times. Think Stripe, mid-2017, growing fast, maybe 750 people, 300 engineers.
A decent size, yeah.
Yeah.
Big enough for complexity to start creeping in, I bet.
You bet. And they did these productivity surveys, right? Every 6 months. And in early 2017, guess what popped up as a top priority? Right alongside better technical documentation.
Let me guess. Something to tame the code base? Maybe related to types.
Bang on, static type checking for Ruby. And it wasn't just a bullet point. The actual comments from engineers, the open-ended stuff.
The real gold. What were they saying?
Things like wanting better code organization, clearer interfaces, less magic. Someone literally wrote static types, less magic.
Wow. So the engineers were really feeling the pain. This wasn't like management pushing something down.
Not at all. It bubbled up, which, probably helped Sorbet's adoption later. It was solving a real problem people had.
That makes a huge difference. Grassroots demand versus a top-down mandate.
And it wasn't totally out of the blue either. Stripe already had things hinting at this, like Odin model back in 2013.
Odin.model, what was that?
Sounds like a precursor to T-struct. It did runtime type validation for their database models, basically enforcing structure at runtime.
Interesting. So even back then, they were trying to add some kind of type safety, even if just at runtime.
Yeah, and around the same time, 2013, again, they apparently had another library. This one was for defining interfaces, checking at runtime if methods existed, and even did some kind of type checking or casting.
So again, trying to formalize contracts between different parts of the code.
Exactly. Then fast forward a bit to November 2016. They introduced something called interface constraints and, crucially, declare method.
Declare method. That sounds familiar.
It should. It's the direct ancestor of Sorbet SIG. Initially, it was all about runtime checks. Think design by contract.
Okay, so the SIG syntax didn't just appear. It evolved from something Stripe was already using internally for runtime guarantees.
Right. And adding more context, Stripe had already adopted Flow for their JavaScript in July 2016.
So they'd seen the benefits of static typing in another language they use heavily? That probably fueled the desire for something similar in Ruby.
Seems likely. Then comes this flashpoint in early 2017. An influential engineer writes this email.
Oh, the Catalyst email. What did it say?
Basically laid out the struggles of navigating their big, evolving Ruby codebase. Pointed to specific examples where static types would have prevented bugs or saved time.
That probably really lit a fire under the idea. Concrete examples make the abstract need much more urgent.
Okay, so the need is clear. Engineers want it. But how do you actually do it? Stripe had, 2 million lines of Ruby? Rewriting wasn't an option.
Yeah, no kidding. Not with constant feature development, so they had to work with the existing Ruby.
And the existing Ruby type checkers back then, like RDL or typed Ruby, they had issues. RDL apparently took ages just to load Stripe's code. Typed Ruby needed a near rewrite.
So off-the-shelf solutions weren't quite cutting it for their scale or needs. They had to forge their own path.
Right, which brings us to the different syntax approaches they considered. And rejected. First up, the TypeScript approach.
Okay, so add types on top, compile them away, like Babel, basically.
Yep, seems logical. But Jake calls it a massive break with Ruby compatibility.
Why? Well, Ruby does expect to just run tests, right? Save a file, reload the server, no build step.
Exactly. A mandatory compile step. Huge friction. Plus, it would break everything. Linters, debuggers, syntax highlighting. Ruby doesn't have source maps like JS does.
Right. The tooling just wouldn't understand the typed source code. And if they wanted to open source it, making adoption that painful is a non-starter.
Totally. Developer experience is king in Ruby, arguably. So TypeScript style was out. What about the header file approach, like RBS today?
Separate.rbs files, or DTS in TypeScript, .pii in Python. Keep the types separate from the implementation. Sorbet has .rbi files too, of course.
True. Gradual typing systems often support this. Big advantage, clean slate for syntax design in those files.
But what's the downside they saw?
The main limitation mentioned is that RBS alone doesn't solve the problem of type assertions inside a method body. You still need something like t-dotlet or casts.
Ah, okay. So RBS defines the boundaries, but you still need inline hints for the checker within the code itself.
Right, so useful, but not the whole picture. Next idea. The JS doc approach. Types and comments.
Like Google's Closure compiler or Ruby's own Yard docs? Seems non-invasive.
It is. Doesn't break Ruby syntax, but remember what the Stripe engineers wanted?
Both static and runtime checking.
Exactly. Comments get ignored at runtime. So a comment-only approach would sacrifice the runtime checks they already had with declare method and really valued.
And those runtime checks were important, weren't they? Jake mentioned that getMC example.
Yeah, preventing no method errors when implementations change unexpectedly. That whole Hiram's law thing, people depending on behavior you never guaranteed. Runtime SIGs help catch that.
Okay, so comments were out because they lost the runtime safety net. Makes sense.
Which led them to the approach they actually took, the DSL approach.
Basically repurposing that declare method they already had.
Yep. Pretty clever, really. They already had thousands of annotations using it. Instant test suite.
And it provided the runtime checking they needed.
It did. Though Jake admits it's kind of wild using a single line method called DSL for this in a language without, like, first-class decorators.
A bit of a hack, maybe, but a functional one that fit their constraints.
And the syntax evolved too, getting shorter. Opus.types.any, no class, string became t-nailable string. The SIG itself changed forms over time.
So iteration based on usage, classic software development.
And there was one more approach they considered, the Python way.
Ah, Python's type hints, PAP, fee4e4, and all that.
Right, introduced way back, formalized later. Crucially, those annotations are actual Python objects available at runtime in annotations.
Which means you can build runtime type checkers on top of them, even though the core checking is static and optional.
Exactly. Jay draws this really neat parallel. Sorbet's DSL and Python's type hints. Both are runnable syntax, both optional. Both allow optional static and runtime checks. Both have reflection APIs.
But the main difference is just the syntax then. Python got first-party syntax integrated into the language.
Pretty much. And that was the rub for Ruby. Getting Python-style type hints would have needed a change to the Ruby VM itself.
A much heavier lift than building a library, especially back then. And that effort seems to have stalled for Ruby, unfortunately.
Yeah. So the DSL was the pragmatic choice. But treating types as Ruby expressions brought its own headaches.
Right, the types or expressions constraint, what kind of problems did that cause?
Well, sometimes the syntax they wanted was already taken by Ruby itself.
Ah, namespace collisions, like operators or method names.
Exactly. They really wanted to use for unions and for intersections, for generics like array integer.
Makes sense, that's pretty standard in other languages. What stopped them?
Two things. One, it would probably require monkey patching core classes like module, which is always controversial,
Yeah.
and often requires opt-in.
Risky, yeah. Can break things in weird ways.
And two, some classes already use those methods. Array is array access, not generics. Set creates a set. Using or on actual array instances does set math, not type unions.
Oh, right. So array integer would try to access an array at index integer, which makes no sense. And string integer wouldn't mean array of string or integer.
Precisely. It just conflicts too much with existing Ruby semantics. Though Jake floats an idea, maybe relax the one-way principle, allow multiple syntaxes for unions, let projects choose.
Interesting. Flexibility versus consistency? A perennial debate?
Another issue with types as expressions, forward references.
Referring to a class before it's fully loaded or defined? Yeah, that's tricky.
And it directly forced a change in the SIG syntax. They started with eager evaluation, like sig.params x mydata.return string.
Okay, simple method call.
But if MyData hadn't been loaded yet when that line was hit, it would crash. Especially nasty with Rails auto-loading, where load order can differ between dev and prod.
Yeah. Load order issues are the worst.
Yeah.
So how did they fix it?
They switched to the block syntax, sig_params x mydata.returns, but the block makes the evaluation lazy. The types inside aren't looked up until the method is actually called, or maybe later by Sorbet itself.
Ah, clever. Delay the evaluation until everything is likely loaded. Python had a similar issue, right, from future import annotations.
Exactly. Same problem, similar solution, deferring evaluation, and the final constraint of types as expressions. Sometimes you just want custom syntax that isn't valid Ruby code.
Like integer for nullable integers. Or clean syntax for function types like integer string.
Precisely. Or using and freely for unions and intersections without them being method calls. The DSL approach forces you into method calls like tnailable, tany, tpros.
Which works, but is more verbose. Other approaches, like a dedicated type language, RBS, or a transpiler, don't have that limitation.
Right, so there's a trade-off. Runtime checkability via the DSL versus syntactic terseness.
So, summing up the journey, they needed types, couldn't break Ruby, needed runtime checks, chose a DSL which worked but had syntax constraints because types had to be valid Ruby expressions.
That's a great summary.
Hmm.
Which leads to, where do they go from here?
What are the potential futures Zimmerman outlines?
Well, some incremental stuff. Maybe build opt-in support for syntax that needs those risky monkey patches.
Okay. For projects willing to take the risk for nicer syntax.
Maybe consider small backwards incompatible changes, like for tuple syntax. Try to make really verbose things, like generic method definitions, less painful.
Sensible refinements.
Yeah.
But is there anything more radical?
Oh, yeah. There's a really interesting idea he brings up, sparked by work from Sutaro, the creator of RBS.
Okay, what is it?
What if the Ruby VM itself learned to parse RBS comments?
Wait, the VM parses comment?
Yeah. Sutara demoed the syntax at RubyKaigi 2024, basically RBS syntax, but inside special comments right before a method definition, like hashtag RBS returns string.
And tools are starting to support this.
Apparently, Steep, TypeProf, and even Sorbet are adding support for understanding types written this way in comments.
Okay, so tools can parse it, but what's the VM part?
The idea is, what if the VM not only parsed these RBS comments, but actually associated them with the method definition and exposed that type information at runtime?
Whoa, so you could ask Ruby itself, what's the RBS signature for this method?
Exactly. Think about what that solves. You wouldn't have to choose between RBS's nice syntax and Sorbet's runtime checks anymore. You could potentially have both.
How so?
You could write your types in the clean RBS comment syntax. The VM makes it available. Sorbet, or another tool, could read that runtime type info and maybe even generate the runtime checks for you based on the RBS.
Ah, so the RBS comment becomes the single source of truth, and runtime checks are derived from it.
Potentially. And it blows away the types as expressions limitations. You could use AM in the RBS comments freely because they're just comments to standard Ruby.
And it solves the forward reference problem too, presumably, because the VM handles associating the comment whenever the class is fully defined.
Right. No more eager evaluation woes. And the benefits go beyond Sorbet. Imagine IRB using that info for better completion.
Or GEMS using it for metaprogramming, generating JSON schemas from struct type hints, maybe.
Yeah.
Liners could use the VM's parsing.
Yeah, tons of possibilities. And crucially, it could be totally opt-in. If you don't write the magic comments, Ruby behaves exactly as it does now.
That sounds actually quite elegant. Leveraging RBS syntax, but making it available programmatically via the VM.
It's not a perfect solution for everything, Jake notes. It doesn't really help with inline assertions like t.let, but it feels like a very promising direction.
It suggests the Ruby typing story is far from over, even without Python-style native hints. There's still innovation happening.
Definitely. So, wrapping this up, we saw the organic need at Stripe driving Sorbet's creation.
Right. The careful evaluation of different paths, transpiling, headers, comments, leading them to the DSL approach.
Understanding that the DSL, while enabling runtime checks, imposed the types as expressions constraint, shaping the syntax we see today.
And looking forward, this idea of VM-assisted RBS comment parsing offers a potentially powerful way to get the best of both worlds: clean syntax and runtime availability.
It really shows that Sorbet's syntax, maybe sometimes seen as a bit verbose or quirky, is a product of very specific needs, history, and technical trade-offs. Form follows function and constraints.
Absolutely. It wasn't designed in isolation. It was forged in the real-world crucible of a large, evolving Ruby codebase.
So here's a final thought for you listening. How does the story of Sorbet's evolution make you think about other tech tools? Maybe ones with designs that seem a bit clinky or non-obvious.
Yeah, what are the hidden constraints or historical reasons behind their shape? It's often more complex than it looks.
And specifically for Ruby types, if you were designing it today, what would you prioritize? Terseness, runtime safety, tooling compatibility, something else entirely?
Lots to chew on there. It's a fascinating space.
It really is. Thanks for diving deep with us today.